This is pultrusion technology, a manufacturing process that involves continuous moulding and the reinforcement of polymers to form high-strength structural parts of continuous length and with a constant cross-section.
In very simple terms, you take glass fibre rovings, which is almost a continuous string of glass fibre, if you like, 4.5 kilometres long, and that is put through a mixture of resin, catalysts, and fillers and other additives, and then drawn into a heated die. So you basically pull this wet string through a heated die, and the heat causes the chemical reaction to create the cure in a thermoset resin. So it goes in as a wet bundle of string and comes out as a solid rod or a solid square or whatever shape the die is that you're dragging it through.
It's taken 35 years for Pultron to get to this scale, from the days when founder Peter Holdsworth figured he could make non-conductive electric fence posts out of composite fiberglass.
He started on the family farm, and he'd taken an interest in this technology, and he decided that he could make electric fence posts because farming was really going to the strip grazing, which is best suited to electric fences. So he started on the family farm, and it was literally an operation in the barn where he was pulling this material through the die with the bulldozer he had lying around. So that's how he started. Typical sort of number 8 fence wire mentality.
Mr. Holdsworth partnered with electric fence manufacturers Kiwitech and Gallagher, and also developed a clip to fasten wire to the electric fence post.
He put a patent on the clip, and he sold the patent to Bill Gallagher for $1 and a handshake and a commitment that they'd buy rods from us, and they've been doing that ever since.
Another early adopter of Pultron's products was Ulrich Aluminium, which used the non-conductive properties of fiberglass to make safe ladders for electricians.
But it's branched out from there into rock bolts for safety in Australian coal mines, to spring-free trampoline rods for the sport and leisure market, to parts for snowmobile tracks, to a rebar to reinforce buildings and infrastructure.
The company's rebar product, Mateen Bar, is twice as strong as steel, a quarter of the weight, non-conductive and doesn't corrode. These properties give it a huge range of uses, particularly in marine situations where steel would rust.
We work with a company called Bellingham Marine we manufacture tie rods to hold the floating pontoon systems together for Bellingham. And again, we're replacing galvanized steel, which eventually corroded, with a composite system. So their maintenance is massively reduced.
The company is 90% export-oriented, and 8 years ago, Pultron opened a facility in Dubai to supply Mateen Bar for the construction boom in the region and take advantage of cheaper oil, which is necessary for the energy-intensive pultrusion process. The factory only produces 20% of the company's product, but is expected to expand rapidly.
Dubai has massive corrosion problems. The seawater there is twice as salty as here. It's 10 degrees hotter, so it's a recipe to eat steel rebar. They have contaminated groundwater, or contaminated ground that they call sabka, which is much more salty than the seawater even.
The Dubai factory has also recently added the Burj Al Arab to its list of customers, replacing energy dispersion units around the waterline that protect the iconic building. But despite such high-profile customers, America's Cup winners Lingy, another one, sales director Pete Renshaw says his favourite project so far has been helping build corrosion-free school buildings in the impoverished Marshall Islands.
You have to find new markets, you have to find new applications, and typically what we do is we will approach a customer with a particular problem, and we'll work together with a customer to develop a solution that's unique to them. And so the advantage of that is that customer will then become almost a business partner, and so you will typically work with that customer for a long time. So, our first ever customers, we are still working with them after over 35 years.
Getting engineers to adopt Pultron's products can be difficult. If an engineer on a project doesn't have knowledge about composite building rods, they can be reluctant to use them and are taking a risk compared to using steel, something they know well. This is starting to change. Canada teaches budding engineers about composite rebar as part of their degree, meaning it isn't a scary item for recent graduates.
There is a huge amount of growth potential in these areas. There's huge untapped markets because of that reluctance and that difficulty. And this is, why I come back to saying that other composites companies we're not in competition with them. They're doing us a favour because they're also helping open up these markets. Every time they make a sale, that's one more engineer who's used this material that's never used it before, so we'll use it again next time.
Pultron has a massive R&D spend in excess of 10% of income and is looking to separate off its machine bar side of the business to get investment partners to drive rapid growth. But despite the expansion, Pultron is still entirely family-owned. It still operates out of Gisborne, where the first fence post was made, and still sees itself as a startup, albeit a 35-year-old startup.
We have a few things on the go, a few R&D projects on the go at the moment. So, the question is which one of those will take off and become the next big project.